Swayam Prabha. Digital India. Educated India.
Hi everyone, welcome back to NPTEL online certification course on research methodology for planning and architectural studies. In our previous lecture, we have discussed about, after collecting data, how then you, go for a data processing, how you can filter some of the missing data and then you can refine your data set. But after that, it is also essential to just have a check on the data and interpret the data for the further analysis. So, definitely any statistical method that you will apply for your collected information will depend on certain assumptions, certain observations that you can do for your collected data, and for that definitely interpreting the collected data is very vital for research purpose. So, with that, today we will be discussing about interpreting data, lecture number 32. So, in this lecture what we are going to learn, basically it is all about interpreting the data and then also the graphical examination of the data. In many cases, before we really do a very sophisticated or advanced statistical analysis of collected information, we try to see graphically about data distribution, what type of information is conveying through those kind of graphical representation, and that can also give you some direction for what kind of statistical tool that you apply for your type of data that you collected. Then we will talk about the missing data as well, like in many cases, like if it is a time series data or it is like a temporal data you have collected for a long span and there might be some sort of missing data. So, how to take care of those missing data? Should we just simply delete it or should we just correct it based on certain sort of statistical analysis and those kind of aspect? But at the same time we also need to look at the data outliers. So, data outliers is something where we will find that okay, in overall data set say 90% or maybe 95%, 99% data representing something, some sort of distribution, and maybe just 1% or maybe even less than that are going to give you some sort of unnatural behavior which are not fitting with those kind of distribution or that is not matching with the rest 99% data. So, in those cases those extreme values are considered as outliers. So, we will discuss that in this particular lecture and try to understand the importance of interpreting data. Now, if we talk about the importance of this particular stage of research process, so it is essential part of any data analysis. You cannot simply do the analysis with the raw data that you collected from the field or collected through experiment. So, you have to first process it and then you interpret through graphical means or through some basic statistical analysis. It attains a basic understanding of the data and relationship between variables. So, either it is something that okay, this is only one variable, there is only one variable, and then you try to see the frequency and other thing. So, normally they are referred as a univariate data, and then if you have say two variables and you want to try to see the relationship, maybe the correlation, how they are associated, how changing one will impact other. So, then that will be something called bivariate, or maybe like that if there is so much of impact of multiple variables, so then it will be multivariate. So, we have to see that depending on the research purpose, depending on your research questions and objectives, you may require univariate, bivariate or multivariate data. Researchers ensures that the underlying data meet all the requirements for the further analysis. Say if you find that the data is not following a distribution, it is not following normal distribution. So, in that case, like probably the mean and standard deviation, those kind of options like parametric options will not be applicable. So, say for example, we will again discuss in detail in one other lecture in the upcoming module about the parametric test, non-parametric test. But for this time being, we know that typically a normal distribution graph look like the bell curve shape, and then you will see that in those cases like you have certain sort of mean value which represented by mu, and then there is some kind of dispersion, okay, and there is some sort of standard deviation. So, those are the important parameters that we also check, okay. Those are the different statistical indicators that we check to understand about the data better, so that we can apply the advanced statistical tool for further in-depth understanding of the collected information. This particular step also guides research to select appropriate statistical methods for data analysis. So, it will also direct the research process or the researcher that what kind of method can be applied. The moment you have some sort of normality test, or you will find the data is not normal or not normally distributed, certain statistical tools you cannot use. So, those are basic assumptions which actually violates, and you cannot go ahead with those kind of tools and techniques to be applied for such kind of data set. In that case, you have to think about something else, alternative statistical tool, where even non-normal data is also going to be taken care of. Now, graphical examination of data. In this case, the objective of using graphical technique is to complement and provide a visual representation of basic relationships among the variables. In this case, level of understanding required for preliminary analysis is fairly simple, but whenever you go for some kind of complex model or complex analysis, you need more understanding, you have to extract more information out of it. So, depending on the complexity of the data and the analysis, it will take time to read. So, if it is something like I just want to calculate the age distribution of a particular population, and we just make a count that okay, less than 10 years, 10 to 20 years or 20 to 30 years, and just make a frequency count that within that population or within the sample how many are falling under that age group 0 to 10 or maybe 10 to 20 or like that. So, this is very simple, but at the same time if we have certain kind of multiple variables and we try to see their relationship among themselves, so maybe we need to go for certain kind of scatter plot or some correlation analysis that I am going to discuss now. Use of graphical techniques can assist in gaining a clear understanding of the diagnostic measures. So, what kind of treatment that is required for that data set. So, it is something you can say that a very preliminary test that doctor prescribe you to detect the problem. So, earlier in my lecture I explained those kind of thing like through a blood test report. So, a blood test report is something which give you some sort of evidence, some sort of counts and proof that what is wrong happening in your body. So, based on that definitely there will be a detection. So, there are specific detection, say for example, if somebody is having fever and the fever is something like a dengue. So, there are specific tests for that. Say earlier also we used to have this RT-PCR test for detection of the COVID. So, like that all those tests, preliminary stage test will give you some sort of confidence and direction to do further investigation. So, that is the advantage, and when you represent it graphically, it will be much more easy for any researcher to interpret. It is something like, you know, the like for a doctor is reading some sort of X-ray or maybe like ECG. So all those kind of notes, and based on that, if there is any difference or any anomaly in the heart rate variability, that can be captured. Now, in this case, what are the things that normally we do? We examine the distribution of data. Many times an adequate perspective of variable is gained through histogram. So, histogram is nothing but a kind of bar chart where it will plot the frequency, okay, the occurrence of that particular variable, or you can say simple word that the count of that particular variables in that particular data set. Say here there is one example where you can see that histogram of some exam grade. So, normally, you know, this is something you must have seen as a student, that you are getting certain marks in the class, or maybe as a teacher, or maybe as a teaching assistant, somewhere you observe that, okay, in a class it is not that everyone is getting the same marks. Maybe the grade will vary, or maybe whenever you do a grading or some kind of letter grade like A, B, C, D. So, maybe many people will come to that particular cluster, but if we only consider the marks as well, so in that case it is a absolute marks, it may be 55, it may be 57, etc., etc. So, in that case, if we can make a frequency and put a range like this, so where you have the marks like 40, 50, 60, 70, 80, 90 and 100. So, within that, just these are the count, that where 40 to 50 there is only one person, okay, 50 to 60 there are 2, then you have 4, you have 5, then you have 2 and then you have 1. So, in this case also, like you can see that maximum student are in the range of 70 plus. So, like that you can simply, you know, through this particular histogram can identify the overall performance or the mean performance or the average performance of the student in that particular class based on the score. Now, similarly, there are other alternative also, which is like leaf diagram. It is again a variant of histogram. It also provides the enumeration of actual data and the values, and this is very interesting. Some of you must have done it maybe in your early classes, or maybe in your school days, but let us understand it once again. Say in a skim leaf, what you normally do, so here it is the number and it is determining the frequency, and this is the first digit of this particular any value. Like say for example, this is something about the age. So, for that distribution, say if I have example like the age group 0 to then you have up to 9. So, 0 to 9 and then you count from 10 to 19 and then maybe 20 to 29 like that. So, all this number in the leaf is nothing but those kind of individual values. So, that means here there is a value called 1, there is another value 1, then there are 2 values of 2, then 1 3 and then you have 4 values of 4, 1 5 and 8. So, there are like if it is something like to be tested in a particular sample population. So, we have 1 2 3 4 5 6 7 8 9 10 11. So, 11 samples, they are below 10, right, 10 years of age group, and individually what are their ages you can represent. So, it is something like you can see that if I read 6 3, so that means it is 63. So, let us understand with another example of the marks. So, say for example, in a particular class of 10 students, the marks are something like 40, 45, 55, 65, 75, 70, then you have say maybe 82, 90, 87, and maybe we can take any random number. So, it is something like maybe again 64. So, if you look at this particular number, so here the lowest number is 40 and highest in this case is 90. So, we have to first create the stem. So, here we have 4, we have 5, we have 6, we have 7, we have 8 and we have 9 as well. Now we have to create the frequency. So, in 40s what are the values available? So, one is 40, so it is 0, so 40 40. Then another value is also there, that is 45. So, then we just simply write 5. So, that means two values are 40 and 45. Now, in 50s only I can see one value, so it is 55. Then in 60s we have two values 64 and 65. It may be in order, it may not be in order, so it does not matter. So, you can write it like 4 and 5. Then in 70s we have 0 and then we have 5. So, hope you understand that how to make it. Now, in 80s we have 82 and 90s we have this value. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, we are missing another value, that is 87. So, this is the 7. So, in that case you can have a frequency that in 40s there are two students scoring 40 and 45. Here there in 50s there is one student 55 and then 60, 64, 65, 70, 75, 82, 87 and 90. So, this is very easy way to count the frequency as well as the individual information. So, graphically it is very easy to do that, and definitely there are certain kind of software which are available. You can also write in certain programming language to create it from your raw data. You can classify the frequency. Moving ahead, so mostly for those kind of examination of distribution, it is normally for a single variable. Here it is score, here it is age. So, you can refer this as univariate. Now, for relationship between variables, normally we take this for two variables together. So, then it is your bivariate. So, many times there is interest to examine the relationship between two or more variables. Scatter plot is one of such kind of graphical representation which can examine the bivariate relationship. Okay. So, here you have this y axis as score and then x axis as study time. So, suppose in one particular study, in this case we are trying to investigate that what is the relationship between the number of hours that you study and your performance in the exam. So, is there any positive correlation that if you study more you can score more? So, based on the collected information, here you can see the scatter plot. It is nothing but a coordinate where x will have the hours and then you have the score point, right. So, like that if you plot all those things in this particular two dimensional plot, you get all those values. Now, in such cases you can see that there are certain sort of linearity, okay, though it is not exactly linear, but it is something like it says that if you study more, it is expected that you can score better in some sort of examination. Okay, so, this is again a particular case, hypothetical case, but obviously it will not guarantee all the time that if a student is studying for 24 hours will perform the best than somebody is like doing for 6 hours. But in a particular example, so this is some sort of representation by which you can identify. In this also you can see in most of the cases the values are like in that particular range, where this is about like between 1 to 3 hours, but below that there is one value and even after that there are only 2 values. So, many a times they are exceptional and extreme values, and we can refer that as outliers, and then we can remove that for the analysis, because they can change the overall statistics. It can make certain changes in the mean or average value that we can calculate. Now, other part of it, when we have certain kind of more variables and you want to compare. So, if you want to compare the group difference in particular study, so understanding the extent and character of differences of one or more metric variables across 2 or more groups, which is also referred as, say, multivariate analysis. There we can use this kind of box plot. So, identification of outliers may become apparent only when data values are separated into groups. So, this is something is very important, and how to read this particular box, this is also referred as a box and whisker plot. So, this is the box and then you have this whisker. So, normally in this case how to do it? So, normally for any particular data you have a minimum value, you have a maximum value, and then within that there will be some sort of median. So, what is median value, what is mean value, we will discuss in detail in our next lecture, but for this time being I am just giving you the mean is something like some sort of average, okay, numerical average of the information. So, it can be done through, say, arithmetic mean or geometric mean. So, arithmetic mean is something where if you have 10 data points, you add all of them and divide it by 10. So, this will be the mean. But median is something where it is something like you are not looking at those average value, but you just arrange those 10 numbers and try to find out the median. So, normally that to be done through arranging all the numbers, and definitely whenever you have some sort of odd number, it is very easy to get the median value. Suppose 1 to 5, if you just try to find out the median, it is 3, but when it is 1 to 6, so then you should do some different calculation. We will discuss that in our next lecture. So, in this case if you see that you have some sort of mean value which is 8.5 hours, but here this is something where you can say this is your median. So, normally in this case we are defining the whole set of data into quartile, okay, 25 percentile data, and then you have 50th percentile data, 75 and 100. So, normally the lower limit of the box is your 25 percentile data, and then the median is 50% and the upper box is your 75th percentile. So, in this case 25th, 50th and 75th, these are the main characteristics where you try to find out that this many number of data, whether it may be the exam marks, whether this may be a score or any other countable form that you collect, you can always see that okay, that 25th percentile, these many informations are available. And then you can see that in this particular comparison where it is something like different year of any investigation of students, and this is the daily screen time. So, in that case it is a comparison between different student from year 1, year 2, year 3, year 4 and year 5, and try to see that okay, what is the difference, group difference. So, here also you get certain kind of data which are like not fit into that particular whisker. So, those are the outliers. Now, talking about the missing data, this basically to identify the patterns and relationship underlying the missing data to maintain a closeness to the original distribution. So, say for example, if you find that okay, in a particular plot you find all these data point like this, right, and then you find few data points which is which are like really away and they are not making any clusters or they are not like matching with the original distribution. So, in this particular case these are becoming outliers, or if they are sufficient in number then that can form a different cluster. So, we have to see that extreme data may not be a wrong data. So, first of all we have to understand that part. So, in such cases like you have to understand those points that which is like which are there, which are apart from those kind of natural distribution. Now, pattern and relationship are result of missing data process, and the practical impact of missing data is nothing but reduction the sample size. So, here if we try to understand it, that if we have certain missing component which can change the dynamics of that particular data or changing something. So, we can actually assume those kind of missing points through that which is near about. So, at least taking the mean and standard deviation. So, other day also we discussed about that when we are going for the processing of data. So, in some cases you can interpret that particular missing data, but if there is some component, suppose you have done some qualitative survey and then you gathered certain information where the informations are like missing in some of the components and then it is as good as of no use. So, in that case you have to remove that entire response. So, then either like you have to go for again data collection or else you have to do your analysis with the reduced number of samples. If that sample is adequate enough you can do that, but if not then you have to again do the data collection. So, you have to be careful for that. Similarly, if it is a secondary data and all, so there might be some sort of data error and maybe you can have different types of missing data. So, then either you interpret so that you can retain the sample or else you have to remove it. So, for that particular case, this is the first point is very important, that you have to identify the pattern of the rest of the data and then you have to take the decision on the missing data to maintain the closeness. So, if something is like you have certain kind of data point converging here. So, you cannot take some missing data from there or maybe it is erroneous. Some of the information which are wrongly filled also, that may also lead to some sort of missing data. So, you have to rectify it as well. Now, coming to this the data outliers. So, observations with unique combination of characteristics which are identifiable as distinctly different from other observations. So, wherever you find that people that probably it is something the students they are scoring in between 60 to 80s in a particular subject and one or two students they scored 100 out of 100. So, they are exceptional. In that case it is not the case, like we cannot say that they are outliers of the class, but looking at the data point and the other values these are totally extreme. So, in that case definitely they are going to impact the overall mean. So, for such kind of cases you have certain kind of removal of those points and then calculate the other statistical parameters like mean, median, etc. Otherwise that may change the overall you can say the interpretation of that particular data that you collect from the field. From a practical standpoint, it can have a marked effect on any type of empirical analysis. So, that is something like we have to be careful and especially look at the data at this stage before you just jump into any statistical analysis. In other hand, when you go for substantive terms, it must be viewed as how representative it is of the population. So, if the population means is a target population for your study, even within that like whatever sample that you are collecting and you get a extreme value, whether this is representing the population you have to check it. So, then you like keep it in your analysis, or you just consider them as outliers and you go ahead with the remaining data set. It can be characterized either beneficial or problematic, but must be viewed within the context of analysis and should be evaluated by type of information provided. So, it is not simply that if any high value is a wrong value or it is a mistake. Many a times it may happen that you can have certain sort of viewpoints, especially for the qualitative data. If you are taking quantitative information, so maybe in that case the tolerance of error or maybe margin of errors are not that big. So, every time if you just try to measure, so temperature or something, that will be much more accurate for a given object. But when it is a qualitative information and then you collect certain sort of rating data or some sort of choice data, in such case probably you may encounter with certain problem that where some of the responses that you collected from your sample are really extreme values, either too low or too high, or maybe it is not matching with other values. So, then that may create problem. But again the previous point, that you have to take that call whether it is having some representation of the population, then you have to keep it, otherwise you can remove it from your analysis. So, with that we conclude this particular lecture, where we understood about the role of interpreting data before going for formal analysis, graphical examination like examination through those kind of frequency diagram like histogram or the stem leaf diagram, or maybe it is a some sort of scatter plot, or it may be something the box plot where we can discuss about those kind of minimum value, maximum value, median, etc., etc. And also we discussed about the role of missing data and what to do with that, and then the data outliers, which are also playing a significant role in altering your results. So, you have to be careful about selecting or not selecting those kind of outliers, and better to take a call before you go formally, before you really go for formal analysis through different kind of statistical tools, right. With that we end it up here, and we will move forward to our next discussion on descriptive statistics, where we will discuss more on those kind of mean, median, mode or central tendency, okay, frequency, etc. That these are first hand you can say data analysis, which can give certain direction and useful information about the information that you collected through your survey or experiment. So, we will be meeting in our next lecture. Till then, thank you. Bye bye.